Okay, so just to refresh from Tuesday's class, there's a formula we can use to figure out how much acid and base we would need to balance each other out, to cancel each other out, to neutralize each other, and that is the titration formula on a reference table. It says that the molarity or concentration of our acid times the volume of that acid is equal to the molarity or concentration of the base times the volume of that base. So if we know the strength of our acid and how much of it we have, like I had that giant volumetric flask full of acid yesterday, we can then figure out how much of a base we would need to neutralize that acid if we knew how strong the base was. So we just need 3 of these 4 unknowns, and then we can always find the 4th one. We'll plug our numbers in, and just remember I did give the kind of updated version of the formula, which was, instead of just, as we're at the bottom here, the normal MAVA equals MBVB, I gave you that sort of update to it, where we're going to multiply all the acid stuff on the left by the number of H's in our acid molecule, because not all acids are created equal. Some have 1 H, some have 2 or 3 H's, and on the other side do the same thing. Do the MBVB, so the molarity and volume of the base, and we're going to multiply that by the number of OH's in our base. I don't know why my pen's not working, it's only writing half the stuff, but that should say number of H's times MAVA equals number of OH's times MBVB. Hopefully my pen works better in the next couple slides, or this is going to be really, really tedious. So as I said yesterday, and as I said on the last slide, if all acids only had 1 H, and if all bases only had 1 OH in the molecule, it would be easy to use that formula. We would just plug in our molarity and volume of the acid, molarity or volume of the base, and get an easy answer. But unfortunately, some acids, like we see here, have more than 1 H in the molecule, so like 2 or 3 over here, and some bases have more than 1 OH, like over here, 2 or 3 OHs. So if we wanted to take this acid HCl and balance it out with a base, any OH has 1 OH to balance out the 1 H in the acid, so that would balance out and neutralize very easily. However, if we had the same HCl acid and we want to neutralize it with, say, this CaOH2 over here, there are twice as many OHs as there are H's in the acid, so we would just need to use more of the acid to account for that. So we update our formula like this: the number of H's in our acid, so just does it say 1, does it say 2, does it say 3, times the molarity times the volume of the acid equals the number of OH's in our base. Again, either it's 1, 2, 3, whatever it says, times the molarity times the volume of our base, and that should work out pretty well for us. So we did at least parts of these 2 first problems yesterday in class. We'll use that same equation up here. Number of H's times MAVA equals number of OH's times MBVB. This equation at the top here, and again, this one is in your reference table. It's just we did do the updated version with the number of H's and number of OH's. So for our first question, it says, what volume of 7 molar HCl is needed to neutralize 0.10 liters of a 2 molar solution of NaOH? You can even write for yourself over on the side what everything is before you get started. So we can write here the number of H's, the MA, and the VA, and we'll find the number of OH's, the MB, and the VB. Seeing if this pen actually works, and it looks like it kind of is, so hopefully this looks better on your screen that doesn't mind. Looking at our molecule here, HCl only has 1 H in it, and NaOH only has 1 OH in it, so we don't even have to worry about these top things. I'm just going to cross these both out. We don't have to update our formula at all because it's just a 1 and 1, so it's going to come out the exact same way. So the MA, it tells us the HCl, we have a 7 molar solution, so I'm going to write 7 as the molarity of the acid. We don't know the volume because it says what volume. We're looking for the volume, so I'm going to leave that blank, and that's just going to be the unknown thing we're looking for. That means we have to have both the MB and the VB, because we have to have 3 of the 4 variables or we can't do our math. So for the molarity of the base, it tells us right here, it's a 2 molar solution of NaOH. So I'm going to write 2 right there. You don't need to write the 0.0 as decimal. And the volume of that base, it says, is 0.10 liters. So the VB equals 0.10. Now I can go and fill in my equation, and I'm going to write again, MAVA equals MBVB. And again, just sorry because my pen seems to be junky today. The molarity of the acid, it says, is 7. So I'm going to do 7 times the volume, which we don't know yet. I'm just going to leave that as VA. And that's going to be equal then to the molarity of the base, which was 2, times the volume of the base, which we see is 0.10. So I can do my math here. It says that 7 times VA, leave that alone for now, is going to be equal to 2 times 0.10, so that is 0.20. I want to get that VA over on the left by itself, so I'm going to divide everything on the left by 7. I'm going to divide stuff on the right by 7, and I get an answer that VA, the volume of the acid needed, is going to be equal to 0.20 divided by 7, and 0.20 divided by 7 is 0.03 liters. I'm going to round that number off 2 decimal places because the number up here, the liter volume number, was 2 decimal places. It's around to 0.03 liters. Someone had a question today in class, what do you do about the units of measurement? Whatever it says, just use that. So if the volume is given to you in liters, use liters as the other unit. And the second question down here, it uses milliliters as the unit of measurement. That's fine. It uses both these things in milliliters. Just match it. Any question that gives you one unit of measurement and you have to figure out the other, just match whatever it says. If it has liters, use liters. Has milliliters, use milliliters. It doesn't make a difference in the math. We don't have to use one unit over the other one. For the second question at the bottom, it says it takes 15 milliliters of a 0.40 molar NaOH solution to neutralize 5 milliliters of HCl, and wants to figure out what is the molar concentration of the HCl solution. Looking at our acid and base, once again, our base only has one OH in it, and our acid only has one H in it, so we don't have to do any updating to our formula. We don't need that number of H's, number of OH's. It's going to be 1, so we'll just leave it blank. However, we can now figure out the concentration of our HCl. So now we're going to be looking for the molarity of our acid. So I'm going to write MaVa equals MbVb. The molarity of the things we're looking for, so we don't know that. I'm just going to leave it as Ma times the volume of the acid. It says we need 5 milliliters of HCl, so that's going to be 5 as the volume, is equal to the molarity of the base. That's right here. It's the 0.40 times, make sure this 40 comes in, times 15 milliliters. So Ma times 5 equals 0.40 times 15, and let's see, grab my calculator this before, but 0.4 times 15 is going to be equal to 6. So now that comes out to molarity of the acid times 5 is equal to 6. We want to get the Ma by itself, so again, we're going to divide by 5 over on this side to get the Ma by itself. We divide then the 6 also by 5, and we get an answer that the molarity of the acid is equal to 6 divided by 5, which 6 divided by 5 is equal to 1.2. So the acid solution has to be a 1.2 molar solution, a 1.2 concentration of acid. Our acid is 1.2 molar to account for the 0.4 molar NaOH. The NaOH is about 1/3 as strong. That's why we need 3 times as much of it than the 5 milliliters of the acid, which makes sense. We have 1/3 the strength of 1, so that means it would be 3 times as strong. All right, looks like my pen works better if I just press down really, really hard. So if my letters and numbers get a little bit big here, we'll just have to deal with it. For number 5, it says how many milliliters of 10 molar NaOH, our base, are needed to neutralize 0.10 milliliters of a 0.2 molar H3PO4 solution. And now we actually see what I was talking about with the different number of H's and OH's in our acids and bases, because it says right here our base only has 1 OH per molecule, but that our acid has 3 of the H's per molecule, so that we're going to have to account for that. So I'm going to write my formula out. Number of H's times Ma times Va equals the number of OH's times Mb times Vb. So my number of H's is right here in the formula. It tells me that there are 3 H's in each acid molecule, so I'm going to write 3 outside the parentheses. And then my molarity of acid, it says right here, is 0.20 molar. So I'm going to write that. 3 times 0.20 times the volume of the acid is 0.10 milliliters, so times 0.10 equals the number of OHs in my base, and that's just one OH right here per base, so I don't have to write anything. So I'm going to just then continue with the rest of the formula. Times the molarity of the base times the volume of the base, and I know the molarity of the base is 10 molar, so I'll write 10 right here, but the volume of the base is the thing I'm looking for. That's the thing I don't know, so I'm going to leave that blank. That's going to become 10 times VB. So I can now do my math, and I'm going to do 3 times 0.2 times 0.1 on the bottom, so 3 times 0.2 times 0.1, and my number on the bottom becomes 0.06 equals 10 times VB. So I'll leave that as 10 times VB for now. And I want to get that VB by itself, so I'm going to divide by 10 over here. I'll divide everything by 10 over here. And my volume of base needed is equal to 0.06, or some number that looks like it should be 0.06, except my pen is a piece of trash, divided by 10, and 0.06 divided by 10 comes out to a volume of base that is equal to 0.006. Trust me when I said it says 0.006. And the unit of volume before used was milliliters, so this is also milliliters. And I'm going to spare you having to watch me struggle through writing another set of math questions here. Hopefully you can figure this out. If not, just go back to the notes from yesterday, and I have to find something better to write with this because this is absurd.